Hello, I'm Brian Bush from the Marlowe team. I'm going to be demonstrating the use of a Marlowe Runtime client with AWS Lambda. So one of the nice things about this is you don't have to install any Marlowe software. As long as you have a wallet that can sign and submit transactions, you can use Marlowe Runtime over AWS Lambda. And what we're going to do is demonstrate this with a simple zero coupon bond contract. This is basically just a loan that someone pays back with interest in one balloon payment. It's also called a bullet loan. And one of the first things we're going to do here is just record version numbers in case we want to repeat this. We're using the AWS command line tool, Cardano CLI, and then Marlowe CLI. Only the AWS connectivity is essential. You could use a wallet for any of these other functions here. And so we are going to be signing things locally and submitting them locally. So we do need a connection to the node. There is a node running in the AWS EC2 cluster that's connected to AWS Lambda, and that's going to be doing a lot of the work. But in the end, the wallet has to connect to a node, and we're going to do this locally. So first we just select the network. We're going to be using the preview test network. We have a folder that has some keys in it, and there are two participants in this contract. We have a lender and a borrower. So we're going to use keys that we've already created for these, a signing key, and there's the address. And we're going to make sure that they have some funds. So they have 150,000 test data. And then the borrower, similarly, they have an address. They also have 150,000 test data. And in terms of architecture, what we have here is in blue, the Marlowe Runtime cluster of services. The chain sync daemon, Marlowe history, Marlowe discovery, and Marlowe transaction are all backend services. And then you can have clients like Marlowe's Runtime CLI. So you can access Marlowe from the command, or you can access Marlowe Runtime from the command line. And there's also a web server in progress that will give you REST and eventually WebSocket access to the Marlowe Runtime backend. What I'm going to show you today is a Marlowe Lambda. So this is an Amazon Lambda service for this. And as you can see here, you also need wallets for all these services because Marlowe Runtime does not manage your private keys. So all the signing has to be done with a SIP30 wallet or some other technique. And the process for if you're going to deploy the Marlowe Runtime client on AWS Lambda yourself, there's a repository you can clone. You enter a development shell, you package things up as a zip file, and then you can upload that zip file to AWS Lambda. So you can do that from the command line, but you can also do it through the AWS console. So basically you just say upload the file, the zip file that's created, and then you can do testing within the console. And then you obviously have to do configuration, set permissions, and things like that. But it's a fairly straightforward procedure. You do have to pay attention to all the details of permissions and similar items. So anyway, I've already deployed that. We can make sure that it's available. So we're just going to list the functions. You can see information about this function. It has an identifier. Now the contract has a couple parameters. So we're going to set the contract to be a loan of 100,000 test data, and with 5,000 test data paid back as interest. We've set a deadline. This obviously is unrealistically short, but for the demo, it's convenient to have short deadlines. And then you could create the loan itself in any tool that lets you output JSON in the correct format for Marlowe. For instance, you could use Marlowe Playground and download the JSON file. You could also use Python or Rust or any other language that can generate JSON as long as it conforms to the Marlowe standards. We're actually, for convenience, going to use the Marlowe command line tool to generate this contract from a template because it's one of the standards in the template. So I've just filled in sort of the blanks in the template here. generated a contract file, and we've run that. So now the first thing we're going to do is take that contract and package it up into a request for AWS Lambda. So it's a create request. We're going to include the contract. We have a few parameters, how much ADA goes into the first creation transaction. In this example, we're not going to use role tokens, but you could certainly do that. And then we're just using one address here. If you had a wallet with multiple addresses, you'd list all the addresses and you could specify collateral. So we're going to create that request, and then you can see that here. It's got what we typed in, and then it has the full contract listed. So that's what we're going to be sending over to AWS Lambda. So here's the actual call we're making. We're using the AWS command line tool. It says success, and we'll just take a look at the response. And so this response is a little bit opaque, but what it's really giving us is the actual transaction that we're going to have to sign and submit. And then it gives us a little bit of information like the contract ID, the type of response, and then the transaction that's going to be occurring. Now, once you have this transaction file, you could sign it in any tool that can sign transactions. So you could use Cardano Wallet, the Cardano hardware CLI if you want to sign it with a hardware wallet, or Cardano CLI. Some SIP30 wallets can also sign an external transaction that you just upload, or you can build your own SIP30 connectivity. But for convenience right here, we're going to use Marlowe CLI to sign the transaction because it can sign it, submit it, and wait for the confirmation, and that just saves a little bit of work. So we're going to extract the actual transaction out of the response file, store it in a txbody file, and this is the file you would actually have your wallet do the signing and submitting. So this can take a little bit of time. The signing's fast, but you have to wait for the confirmation of the transaction. So we'll just wait a minute for that until that happens. And there's the transaction ID. You can actually see that matches the transaction ID that was predicted there. So everything's okay. It hasn't been altered. And then the contract ID in Marlowe Runtime is actually just the UTXO for the very first transaction that created that contract. So we're just going to pull that out of the response file that we have. There's the contract ID. And then we can query the blockchain, and we can see, yes, there's 3 ADA there. We have the hash of the datum that's stored there. And once again, you could look at this in Cardano Explorer or other tools. Now, there are other things we can do other than just creating transactions. We can retrieve information about the contract. So we're going to create a GET request, and this is really simple. We just say we want to get information about the contract, and here's the contract ID. So we're going to create that. And once again, we'll call AWS Lambda. It comes back quite fast. And then we'll look at the response. So what do we have here? We have information about the contract as it appears on the blockchain. And this is essentially complete information about the contract on the blockchain. So we have information here about what was in the output, where it went, the datum in the contract. So we can see the Marlowe contract itself here. That's on chain. And then Marlowe parameters, we weren't using roles currency in this contract, so that's blank. And then the current state of the contract. Later on, when we do more transactions, we'll see additional steps to the contract. And actually, we'll do that right now. So first, the lender has to deposit the loan amount. And once again, we're using JSON. All the interaction with Marlowe is through JSON files. We could create this with any JSON tool, but we're going to use, for convenience, the Marlowe CLI tool. And it will create a properly formed JSON file with the party, the account, and the amount. And so we'll splice this in to a request. So we're saying we're applying inputs to this contract ID. We're going to splice them in right there. And then we give it a validity range for the transaction, change address, no additional addresses here. But once again, if we were using a wallet with multiple addresses that are active, we could list the other UTXO addresses that could be spent. And then we're just going to use defaults for collateral. So when this is all assembled, we see the information we entered and then some simple JSON around the party. So this is getting repetitious. You just submit this to AWS Lambda again, and then we'll look at the response. We get another body. This is a bigger response because there's a little bit more going on here. You can see what the transaction will be, and we will sign, submit, and wait for confirmation of this. So now the lender is depositing the ADA. The contract actually immediately pays that to the borrower so they can use it. And we can see what's going on at the contract address. So Marlowe contracts have sort of a universal address, modulo state keys, and we can compute that. This is basically one Marlowe address for all Marlowe contracts of a particular version. So there's the address, and then we can query the blockchain and see that the new transaction has occurred, and we still have the min ADA at the address, but the script hash has changed because the internal state of the contract has changed. And in a blockchain explorer, you could look at this too. So next, we will take another look at the information on the contract. And what we're going to do here is we already prepared a GET response, so we're just going to reuse that. But it'll be different now. So I should say a GET request. The response will be different. We still have the creation transaction. And then now we have steps appearing here. And this is one step so far because we created and we applied one deposit to it. But you can see information of the redeemer, the output, and then the datum, which is the new contract and its internal state. So we will next do the final stage of the contract. Once again, we're generating a deposit. This time it's the borrower, and they're depositing the principal and interest. They've paid back the loan. Everything's done. A lot of time would have passed in real life here. And then assembling the request very much as before with the previous deposit. It's just that the borrower is doing it. So we invoke the Lambda response, and then we'll take a peek at it. Everything looks okay. If there had been an error, you would have seen an error message here instead of the body, but everything's fine. And then we will submit it locally and wait for the confirmation here. And now, since this is the closing of the contract, there won't be any ADA left at the script address. The minimum ADA will be paid back to the creator of the contract, and then all the payments will be made, and we can take a peek at those in a minute. Okay, the transaction was confirmed, and once again, we're going to look at the script address, and you see there's nothing there from the contract because the contract is over. We'll look to see the lender. They have their interest received, and the borrower is down the interest that they paid. You can total these up and compare them to the 150,000 ADA they each had originally. And then finally, we're going to reuse that GET request and then look at the GET response. And here we'll see we now have two steps. So we had the one for the first deposit, and then the second step is shorter because it's closing the contract. It just has a redeemer. There's no datum because there's no continuation, and you can see the amount that was repaid and where the addresses were. So basically, that's a simple contract being run with AWS Lambda that's connected to Marlowe Runtime. Thank you.